little brash, but in one case I actually did dunk my hand in there. Showing them how it's actually working is really how you make a move into these fields.
Eric, thanks so much for joining us today.
Thanks for having me. Pretty excited to be here.
Now tell me what you guys are building at Maverick.
So at Maverick, we are designing, developing, and producing the chemicals needed to extract all the critical resources, whether it be oil, gas, or critical elements like lithium, gold, uranium.
Tell me about the old way the industry did these things and then what Maverick brings to the table here.
Yeah, so the traditional legacy methods are pretty disastrous. They're bad for the environment, and worse, they're inefficient. So for certain elements, let's say gold, for example, you have to mix mercury. Mercury is neurotoxic. You get the gold ore, you mix the mercury. In certain locations, they actually still mix it by hand. And eventually you get a gold alum. What we do is we pump in our chemicals. We don't even have to dig a mine. We essentially do in situ recovery, where we dig a small hole, pump our chemicals down, and bring up the gold as if it were water. And so it's much cleaner, much faster, much safer, and ultimately much, much cheaper to produce these chemicals. And we do the same thing with oil and gas. Instead of pumping down sulfuric acid, hydrochloric acid, pretty toxic chemicals, we just pump in our biologically produced chemicals. That fractures the ore body and takes everything of value out.
Wow. So let's back to gold for a second. I picture this as like a big lump of rock and other things, and the gold's in between.
Yes.
Does your chemicals kind of eat away the rock and just the gold remains?
We eat away and nothing remains. So essentially, we break everything apart.
Okay.
Everything apart, and it goes into a solution. And so it's much faster to move around water, move around liquids, than it is to bring something hundreds of or thousands of feet up from the surface. And so we essentially mine gold as if it were water coming out of a well.
So it all kind of melts together?
Yes.
And then what happens next?
Then we run through a process. We essentially take out all the crud, all of the sulfur, the sulfides, the silicates, and what we're left with is a soup of critical elements, whether it be gold, iridium, which are typically found together. And we separate them based on some are valuable, some are not. Gold, of course, is valuable. And we run it through resins. And those resins allow us to take certain metals of value out.
Wow. What are these chemicals you guys using? Because it sounds like you said, this sounds like very powerful stuff. The idea like you're melting a rock.
Yeah.
That scares me a little bit. Like, what are these? What are they made out of?
Biology.
Okay.
So in short, they are proteins. And the way I found them was pretty interesting. So I'm a member of the Explorers Club. Every year I try to go on an expedition. And 2022, I was in the Arctic. So I was in Greenland, in northern Greenland, around Kangerlussuaq. And just how you and I do respiration, we need oxygen. Mm. Oxygen has to bind to iron. And so bacteria are the same way. They need iron, but there's no iron up there. So they naturally produce these chemicals, they spit them out, and they melt the rock to take the iron out.
No way.
What I did was I found the bacteria up there, took it back to the lab, and said, how can I overproduce this chemical? How can I make this chemical even stronger? And so I didn't invent it. I essentially found it in nature and adjusted it to fit the industry.
It sounds like these are bacteria creating a tiny amount of the substance.
Yes.
And you're obviously dumping it into mines. I assume there's a large volume of this.
Yes.
How do you mass produce it?
We re-engineered existing infrastructure. So bioproduction is really the thing that's holding back synthetic biology and biology at scale. We can produce very simply a couple of liters here, a couple of liters there. But when you're talking about kiloliters or megaliters, in some cases we're producing for certain mines millions of liters. We actually have to find totally new ways to do it. So one of the cool things about biotech is that it scales interestingly. It doesn't scale one-to-one, just how it doesn't matter whether a cell in a mouse or a cell in a great white. Very different sizes, but the cell is the same. Mm-hmm. So we have to change the entire organism. And one of the easiest ways that we found was actually re-engineering sewage pits. So right now, most of the sewage pits in America, where sewage goes to be treated into potable water again, relies on bacteria. So we took one of those, we re-engineered it as a fermentation vessel, and that's what actually allows us to produce as much as we want.
Wow. What is this chemical called?
Lithex.
Lithex.
So lithex, if it's for mine, lithex is from the Greek lithios,
Okay.
rock, and petrox for the oil industry.
Gotcha.
Yeah.
If like I stick my hand in the stuff, not a good idea.
Safer than acid.
Okay, so
Much safer than acid.
this
but I
stuff can
wouldn't do
eat
it.
rock, but you can transport it, and it's doesn't hurt.
Yeah, it doesn't really hurt anything unless it's in the specific oxidation state.
Okay.
So it's much safer, and that's really one of the main selling points. If you are producing and shipping large quantities of acid, of corrosive equipment, that is going to eat into your margins.
Mhm.
So if we can make a non-hazmat version of these, then we've just eliminated up to half the cost, because half the cost is transporting a hazardous material.
Wow, crazy.
Yeah.
Tell me about like I heard about this. You went on an explorers club and you found something. You found a whole new business model.
Yeah.
But your background is biology. Tell me about like how you went from. Tell me about your background in education and how you got into this world.
Yeah, so my background is actually medicine.
Okay.
Medicine, synthetic biology, toxicology. Before starting Maverick, I was actually working for the military, and we were developing antidotes for chemical weapons.
Mm-hmm.
So sarin, nerve gas, for example, VX, all of these chemical weapons have a very similar crystal structure to rocks, actually. One is phosphorus, one is silicate. And I figured I'm really good at breaking this stuff down. So we actually made viruses that go into the human body, break down these chemical weapons in situ or inside the human body, and they worked perfectly. So I thought, can we adapt this to break something else? Can we adapt it to break down carbon plastics, for example, or silicates? And yes. And so that's where I got the idea, and I needed to find that base. And that's what took me to the Arctic, and actually took me all over the world. So I try to do one expedition a year. Last year, we recreated part of Darwin's 200th anniversary of the Beagle.
Wow. Okay.
So I sailed a couple hundred miles along the Pacific, taking DNA samples from everywhere. Later this year, I'm going to the South Pole. So we're actually sailing from Chile all the way to Antarctica, collecting more DNA samples and seeing, can we expand the portfolio even more?
Where were you working when you kind of saw this bacteria eating the rocks? Were you at a current job or did you switch?
I always wanted to study medicine.
Okay.
I actually dropped out of medical school. So it was a hard decision, dropping out of medical school with a full scholarship to be a Navy surgeon.
Wow. Okay.
And so, interesting conversation, told my parents I'm dropping out, and I'm going to California and doing a startup. Moving to San Francisco, going to Y Combinator. And then during Y Combinator, that's where I actually developed the science, where we actually went to the Arctic, took the samples, and advanced it to this point.
Take me into your mindset, because you were, studying a very, highly qualified, highly specialized path.
Mm-hmm.
What made you decide to go in a whole different direction?
Well, what drives me really is seeing an invention make the jump from the lab to actually helping someone. And that's very clear in medicine. The problem is it takes years. From I found this new drug to this drug is helping people, it's about 14 years on average in the US. With industrial biotech, it's weeks, it's days in some cases, that we can actually develop something and have it put into practice. And that's what really drove me to say, well, if I can make the biggest impact in industrial biotech, I should.
Studying to become a Navy surgeon and then running a company, two very tough jobs, but different skill sets. What do you know about starting a business? Have you always been studying entrepreneurship, or did you just say like, I'm going to go for it? Like, how'd you learn to, you're in study academic mode and now you're in founder company running mode. Tell me about that switch.
Yeah, it's very different. But ultimately, the basis is the same. You need discipline. You need very highly ordered mechanics. You need your people to understand what is the goal, what is the overall reason why you're here. Why are we all working on the same project? And I think that's very similar in entrepreneurship and in the military. And I think the leadership aspect of it as well.
What was it like being in Y Combinator? Because I know there's all walks of life, but I'm sure there's a ton of software and AI. Like right now, there's a lot of tech.
Yeah.
And you're doing tech, but you're doing biotech. You're creating, enzymes that eat rocks. What did people think there, and like tell me about that experience with the other startups?
Oh, it was awesome. Funny story. I actually asked Sam Altman what an API was. I still have no idea what an API is. I'm not computational, but everyone looked at me like, what? Then someone in the background like, no, he's biotech.
Yeah.
It's okay. So that pretty much sums it up. We were surrounded by amazingly smart people doing crazy innovation, and we took advantage of it. We started asking questions. How can we use this computer model to increase the production of our bacteria? How can we use this large language model to make reports as fast as possible and as efficient as possible? So that really helped us play off other people. And the same happened with us. We have calls all the time like, hey, what if we changed this with our protein? What if we change that with our production method? Who's doing your design and engineering at scale? And so it's a pretty collaborative environment, but just picking and choosing and then being open to help other people.
How do you guys make money, and what is your business model?
Yeah, excellent question. So how do we make money? We essentially sell protein. We sell our chemicals to both the mining and metallurgy space and to the energy space. So for example, an oil well in Texas, we're currently based in Texas, is considered fully exploited when only about 30% of the oil has been extracted. So what we do is we sell our chemical, we pump it down into old oil wells and break the rock, break everything apart. That takes up the oil, takes up water, and it takes up all the metals that are inside there. And then we take a cut. We take a cut of the metals, we take a cut of the oil, plus selling our chemical. For the mines, we actually just sell the chemical. And the mines are operating at such a large scale. For example, a heap leaching operation that we're working with is 200 meters by 300 meters by 2 kilometers long. All of that has to be irrigated with our chemical. So we're essentially a chemicals company.
Oh. And in terms of, you mentioned with the oil companies, do your team have to then, do you teach them how to use it and then you have to extract it? Is that all your side, or you just kind of give them the product and they know what to do with it?
No, it's definitely a collaborative environment. So oil companies are very good at taking up oil. They're not so good at taking up metals and taking up water and treating the water. So there essentially are 3 different business models in there. There are 3 different revenue sources, and we work pretty close with them. Sometimes we produce lithium, lithium carbonate, lithium chloride. Other times we produce gold, platinum group metals, and then other times uranium and thorium.
Wow.
And so all these have such unique business cases and engineering roles that we have to play. It's a pretty exciting role.
It was a while that before all that stuff would just be left in the ground, but
Yes.
now all this extra value is coming up, especially, you mentioned like lithium and things where like there's such an appetite for batteries and everything. That's wild. How many employees do you have?
Currently, we have around 25.
Okay.
Yes. And it's pretty much spread around biology, chemistry, engineering, design, and a lot of it as we're starting now to grow the business. So getting more salespeople, getting more people that can actually go out and interact with these customers.
That's so cool. How much money have you raised?
We've raised 19 million so far, and we're going to start off our new fundraising mode. Next fundraising is set to begin next quarter.
What's your advice for raising money for somebody?
Be direct. Tell people exactly what you do. Tell people how you raise money, and ultimately have a clear path forward and make that path forward very, very clear to everyone, to customers, to investors, to your own team.
What's been the biggest surprise going from the medical field world to the mining and just the startup world?
How fast everything moves, which is good and bad. In medicine, like I mentioned, it's 14 years from I developed a medicine to this medicine is in someone helping them. Customers don't think in terms of years in oil and gas. It's, you have a chemical, please send me 2 truckloads tomorrow. That's insane. That's great for business. It stresses out scientists. And so that was a very interesting way to change our thinking about it. And ultimately, it's really to our benefit.
What's like the best mindset for someone who's going from one field or one career to another? Because you made a big switch. Like what goes through your head, and also what's a great advice for someone who's looking to make a big life change?
I would say it's all generally the same. An atom is an atom, no matter if it's in a human body or gold in an oil well or gold in a mine. Atom is an atom. So go back to the fundamentals, figure out, do I have the skill set to actually make that jump? In a lot of cases, yes. We just have to really think, what is the basis of this jump? And then what is the basis of each field that we're jumping into? And then don't be afraid. You can always go back. And that's sort of what I told my parents. If this doesn't work out, I'll just go back to medical school. You'll have a surgeon in the family. And so far, I haven't had to go back to medical school. So it's pretty well.
That's terrific. You mentioned, working with Y Combinator, working with all these technologists. How do you view AI? Are you using AI at all in your business, in developing chemicals, or is that just not part of the game plan right now?
Yeah, no, we definitely use AI, and we actually require it from all our scientists. If it can decrease their workload, it should. And it's doing some things that are pretty interesting. So we design DNA, we design some of the viruses that we use to actually produce the bacteria, to induce the bacteria to produce our chemical fully with AI. So it's interesting. It's also scary how easy it is to fully design a virus, produce it, and actually have it shipped to you almost fully with AI. It's pretty insane.
Who ships viruses?
Lots of companies in the US.
You just order up a virus and they make it for you?
Yep. It only takes about 2 weeks. 2 weeks, no background check, no questions asked. Sort of scary. Coming from a background in biological and chemical warfare, there's a lot of stuff that you can do.
Is there other checks on these things?
Not currently.
Okay.
Not currently, and because of AI, we can actually go around any checks that there would. So the easiest check would be, are you producing something that genetically is similar to something that would harm you? So you can't print smallpox DNA. You can't print the plague. But with AI, you can actually change the letters of the DNA code and have them emulate that. And so it doesn't get picked up as being smallpox, but the actual virus would work the same way as smallpox.
When you create like a new bacteria and create a new virus and then create these compounds, does it have to be cleared by the government?
No. So the US is very permissive, and that's both a good and bad thing. Our collaborators in Europe and our friends in synthetic biology, they have such a hard time even ordering GFP. GFP is green fluorescent protein that comes from jellyfish, actually, and it's really good at telling researchers where you're producing protein, which cells are viable, all of that. They just can't even get that stuff because the EU has so many regulations. When I was taking samples from New Zealand, from Australia, the amount of paperwork I needed to get to transport one test tube of dirt was insane. And then here in the US, it's completely different. But you can also see it in the biotech. Biotech in the US is just booming. Biotech everywhere else is sort of dragging itself.
Wow.
Yeah.
You obviously, I want to talk about sustainability is a big deal, and you are a sustainability play. Tell me about kind of the mission and how sustainability plays a role in your business.
Yes. So currently, we are still producing a lot of oil. We're using a lot of oil. That's where our energy comes from. We're moving forward and producing wind, solar, nuclear, but all these require critical resources. So we know that we're moving into higher lithium capacity. We're moving into nuclear reactors with thorium, with uranium. We can produce them, the legacy methods, acids, roasting, fracking, but there has to be a better way. So we're sort of preempting that and essentially saying, we'll treat the legacy energy, which is oil and natural gas, make it much more efficient, make it much more green, as green as you can make oil and gas, but also all the metals that are going to power the green revolution should be also produced as efficiently and as non-invasively as possible. So for example, a copper mine, sometimes when you think of a mine, you think of a hole in the ground.
Yeah.
You think of a massive sprawling complex of tunnels. It doesn't have to be that way. That's very harmful for the environment. So what you can do is, or what I was thinking, what if you can produce metals as efficiently as we produce oil, where once the metal is gone, once the mine is essentially up, all that's left is a little hole in the ground because we've melted all the rock, we've taken out all the metals, and then we've actually refilled that cavity with CO2-based cement. And so can we even take it one step further and produce carbon negative metals? And so far, yes, that's where we are.
Wow, it's wild. Is there a business philosophy that is important to your life? And tell me what effect it's had in your business so far.
Efficiency. A lot of B2B SaaS is very inefficient. You have time to make adjustments. You have time to release a beta and then see how Customers like it, change it. You don't have that luxury in oil and gas. You don't have that luxury in mines. These are very different than the move fast and break things as we're taught in YC, as we're taught in Silicon Valley. It has to work. It has to work the first time. If not, people can die. People can suffocate. These mines are operating with acids. They're operating with hundreds of workers. These oil wells are at 8,000 PSI. There's no room for mistakes. And so getting it right the first time, and making sure that it stays right is pretty much our philosophy.
So Eric, you're a young guy and you're operating in traditional industries, capital intensive, some methods in mining and oil probably haven't changed in 100 years. Yeah. How do you get credibility in this business when they see this young kid with this crazy idea and new product? Like, how do you break through?
Yeah, so I'm 27, definitely young, definitely much younger than the average miner, than the average oil engineer. Something I noticed that was interesting was when I was in the Navy, no one questioned it. It's, oh yeah, the lieutenant had this report, cool, perfect. Here, people just care about the science. No one cares what your experience, no one cares about where you worked, what you did, what you look like. It's, does your product work? Show me the results. Show me that you're gonna take out more lithium, that you're gonna take out more oil, that this is safe. And so being results forward is really how we get our customers and how we gain that credibility. And it's where I'm most comfortable as a scientist, showing the results first.
I was gonna say, how do you prove that your method is more efficient and safer?
A little brash, but in one case I actually did dunk my hand in there. I got a bucket, dunked my hand, and said, because I'm not made of silicon, nothing has happened to me. Nothing is happening to me. Then I dumped a little core sample from a mine site, and you can actually see it start to dissolve as if it were acid. And showing them that I'm really willing to put the money where my mouth is and take a risk really got them a little bit more comfortable. And then showing them the results, showing them how it's actually working, getting them excited and showing them real data is really how you make a move into these fields.
I love that example with your hand, because there's the old business cliche of you have to eat your own dog food. And by staging that bold stunt, you had a big bowl of dog food for sure.
Yeah, and my hand survived.
Perfect.
Awesome.
Love it.
Thank you.